Okay, my outstanding friends, Roger once again, and today we're going to be looking at a meteorite. And this is an iron meteorite. See the little magnet here? It's magnetic. Now, when the iron meteorites come through the space, they actually smelt. Smelting means to burn off all the cheap stuff. Now, the bigger the meteorite, the more cheap stuff burn off. This is a very small iron meteorite, so it's still got a lot of the cheap stuff. And I have it in the microscope right now, this little microscope, telescoping microscope, and I'm going to show you it is virtually identical to what they are showing here, which is what they're claiming to be a new minerals. There's new minerals that they say they found. Now, let's see if I can show you them in my microscope. I have to turn the lights off. Now, remember these structures. You see these little things? They're in the black here, these little black globular places, primarily in the black. And then they found some other stuff. But let's see what I show you. Remember the meteorite right there? Here it is in the microscope. Now, you remember those little white fibers? There they are right there. All right, and this is that black matrix. All right, now these are the white fibers. And the reason they didn't burn off of there is because it's so small. And the same thing there, those are those little fibers in these black matrix. The rest has turned to metal because this was a bigger meteorite and it smelted more. Now we're going to be looking at this very closely in the microscope. And you see that red spot right there? I'm going to show you biology here in my microscope, in my meteorite. And I'm going to show you biology in this one. Hold on a second. Because it's all biological. I'm sorry, everything that there is, as far as I can determine coming out of space, is biology. Alright, you're going to see this, or you have seen it. They're claiming these are new minerals they've never seen before that came through space. Well, I'll show you my meteorites, and I have these same exact minerals. And there they are right there in a microscope. Let's take a look. Well, let's just start and take it as it comes. You see this? Two minerals never seen before in nature discovered in an asteroid that fell to Earth. Remember I showed you that little red spot? Look at that red spot right there. That is blood. And this was biology. And this was where the blood entered this, whatever it was. Now, there's a lot of metal here, so there's a lot, blood turns to metals. That's what happens. When it smelts off in the blood, it turns to metal. And you can see red spots here and there. And all of that stuff was where blood entered and serviced through this piece of biology, whatever it was. And I've seen these everywhere. I've shown this many, many times. And mine here, I have two meteorites. The one I have in the microscope I showed you is right there, and there's the flakes that they talked about. And I'm going to show you another one that came in that cooked off in a different way and is not a lung, which is in my microscope. It is a fingertip. And it cooked off totally different. And I believe it came in with the rotation of the Earth, so it didn't fry up like really bad. Alright, I'm going to make some claims about this, whatever it is. It's biology, one way or the other. And that red spot is basically the same stuff as I have the red spots in my meteorite here. This is an iron one. I didn't cut it, but it is iron. It's magnetic. This is also a meteorite. Now, meteorites come through space in different ways. They come through with the Earth rotation or against it or sideways. It depends. And when they do, they cook off in different intensities and impacts. Let me show you, but I can tell you right now, that is a meteorite. And it cooked off, I believe, coming in with the rotation of the Earth. Let me explain to you how this would form like this if it came in with the rotation of the Earth. Because this is biology. This is biology once again. And I will show you, it's exactly identical to this. You see that? Even the hook. You see the hook right here and the hook? You see that? You see that dot right there, and that dot right there, and that dot right there, and that dot right there? Those are blood vessels. You see this blood vessel here and blood vessel here? These blood vessels exploded because it was wet coming in through space. This is a terrestrial fingertip from another giant. These are giant fingertips. It's identical, look at it, identical, and no difference whatsoever. Even this thing down here, you see this gnarly looking thing? This is just a gnarly looking thing here. There's no difference whatsoever. Because they're both fingertips from giant creatures. I don't know, they look like human beings to me. Now, that's got still blood in it. And it's probably fried up pretty good, and so the blood isn't, like really human. The DNA is not going to be in there, I don't think. This one here probably has some substantial DNA left in it because it didn't come through space. Once they heat up, at a certain degree, it destroys the biological chemistry. This never heated up to a degree that it would do that. But you see all the little fabrics in this? I'll show you this in a microscope as well. Everything coming through space cooks off, and you're going to end up with these little flakes if it's small enough to maintain. Now, I don't know even if they're in here. I'll see if we can find any, but this should have some. I think we might be able to find some if we look around enough with a microscope. They all have these fabrics, like these little white fibers. They all have them, and I have hundreds and hundreds of them to show. Okay, here's that giant fingertip that came through space in the microscope. It's wet and it's drying up right now. You see all these little balls? These are what's called interstitium balls. They're everywhere, and you can only see it when it's really wet now. You see the black, then the red, and we're going to see these fibers show up in a minute as the thing dries up a little bit. And this has the fibers, it has the blood, it has the vessels, it has the fabric and everything. All of this came through space. And I'm going to explain to you very clearly, I hope, in a moment. Now, let me just dry this up a little bit. I'm put a little dryness on there. Now, what are we looking for? We're looking for those fabrics, those little white flakes. And they are all over here. All right, let me see if I can find a better spot to show them. And then as they dry up, they show up better. But all this is the fabric of the tendon strap. These are all little, as the tendon strap cooked off, that's what was left of it. And it's still got some blood in it. I bet you if we put some hydrogen peroxide on there, it'd bubble like crazy. Because it's still got literally red blood in it. Now let me go find some of those white flakes. I got a bunch of them on here. Well, this is a patch of them in here, but they're not really like the little, well, here's some right here, these little bars, you see them? I'll find a good spot, hold on. Okay, my friends, this is the meteorite that this fellow found, that they cut the slab off the end. Now, notice this very roundish part here, and then you have this spot and this spot. Kind of interesting. And then when they cut the slab off of here, you see this shape. And if you can focus your eyes, you see this round spot here? That's kind of whitish looking compared to the rest. You see that? You have to really be able to look at things carefully and understand what you're looking at when you're doing this kind of work. Very, very important to see the details. That whitish stuff there is different than this grayish stuff around it. Now there's another whitish looking area here, and there's another strange looking area here. And then this came off the back of this. So they cut it, they opened it up, and they turned it this way. All right, now, I have, I believe, one of these exact same items here. Didn't come through space though. Now you see up here, you see that? That structure right there? Alright, now at the end of it, you see this? This is the end. Now I broke this piece off right here, but this piece flared right out exactly like that flare is there. It flared right out to here. Just like this flares out on the other side, just as that does. Just as this circle here is this circle here, which is this circle here. Now, this one had some of this stuff burnt off, because a lot of this is flesh. This is a body part, and this is a fingertip. It's a fingertip. It's been DNA tested, CAT scanned. I'll show you the CAT scans in a minute. And these are this is the bottom where the pads of your finger are. You have the same pads on yours. And here is an apical tuft. You see that little round spot right there? You see that little tag coming off? That's this right here.
This is a reminder.
Alright, so don't forget now. This circle is this circle right here. And that's where the bone was. This right here is where the blood supply is. You can actually see the little dimples in there where the blood went through here, because they don't, the veins and arteries don't change like the other parts of the fleshy and bony things. The veins and arteries have little just tubes around them. You can see these are veins and arteries, and so is that. And I had the same thing here, and then this side I broke off just to see what was in there. But in the CAT scan, it's complete, and you will see all of this. And you'll see there's a tendon here, the bone is here, and that's what he's showing right there. Now, we're going to get deep into these meteorites, and we're going to look at all the different types, because all of the different types I can explain. I have them here right now. Here's one right here. It's a little iron meteorite. Here's the magnets on there. It's not falling off. But it's a small one. The bigger they are, the more they smelt. Smelting, as I told you, I understand this process very well. Smelting means how hot you heat up a certain substance to. And when you do, all the cheap stuff, the low-end molecular stuff, atomic stuff, burns off. It just burns off and turns into slag. And then you end up with your metals. And that's what happens when they come through space, because they're scrubbing against the atmosphere of space coming through our atmosphere. And they heat up and they glow and all those little things, and you see all the smoke coming off, and then they hit. Now, if they stay intact like this, you end up with a pretty good preservation. And most of them are quite well preserved. The Willamette meteorite is gigantic. It's absolutely huge, and it is identical to that right there. It's a lung, which this is a lung as well. And the Willamette meteorite, and the lungs are just 100% saturated with iron. You see that? That red? That's iron. Iron is in the blood. There's two types. There's the FeO2 and FeO3, which is the 3 is the oxygen one that we use the extra oxygen out of, and then the O2 is your vein blood. And that they change a little bit in the meteorites. But I could show you all of this stuff in extreme detail. I could show you the actual blood inside of an iron meteorite. Let's go look at that right now so that I can establish some credibility here. Okay, my friends, this is going to turn into a ramble, because there's so much involved in this that I just sort of have to bring you through the research with me. I'm pretending like I just never knew anything about this, and I'm just starting to understand it. And I'm looking at an iron meteorite or a metal meteorite. I don't think anybody would disagree with that. It's sliced. Now, as I examine this, I look at these different crystal patterns. I say, well, what is that from? And I do understand it is from different types of metals. And these are the transition metals right in here. And these primarily are what are in your blood. You know, there's all these other stuff is in your blood too. But this transition metals, what they do is they move molecules through your body. And they need to latch onto other molecules. So that's why they have these crystal patterns. Just think of it that way. They're all a little different, and they all click to a different type of chemistry. Now, what is this and what's that? What the hell is going on there? What is this? And why is this all crunchy like they're on the edge? Well, let's examine these first. I'm going to come in real close here. Let's see. The first thing I see is there's two different colors there. The one on the top is red. Let me come in real close and see if you can see that. That's red. I think you can see that's red. All right, now, let's see what we got when we come back out of here. We got black. What the heck is going on there? We got red and we got black. And then over on the edge, what do we have here? We have some scruffy looking reddish, scruffy looking layerish stuff. What is those layers? And they are not the same as the metal. This is totally different. The surface, well, not totally different, but quite different. And I will show you, I have a meteorite here, which is similar, and I will show you exactly what these things are. So again, this is going to turn into a little bit of a ramble. It's just going to take some time to do. But I showed you, this is red blood, and that is the vein blood. This is artery vein. This is metal. Metal is in the transition metals and all these different metals that are in blood. Blood is literally 100% metal almost. When it burns and boils off all this cheap stuff, you end up with a metal. This is probably a heart, well, I think this is probably a liver, because it doesn't have a lot of plumbing in it. It has, but has a lot of metals. And that's what livers have. Now, a heart and a lung, different story. They have a little more plumbing, and they have, especially the lungs. The lungs will come out looking like this quite a bit. As a matter of fact, this is a meteorite lung right here. You see all the holes in it? That's a lung. And I can actually prove that is a lung. And I am going to show you there is still red blood in that lung. And that is a meteorite. It came through space. When they're small, they don't cook off all the cheap stuff. They just don't get hot enough. That's the key. It's temperature related. The bigger it is, the hotter it is, the almost it turns into 100% iron and the heavier metals. Let me show you the Willamette meteorite. And again, the Willamette is just exactly like this, only it came through space and everything cooked off except the metals. You can still see some red blood in these cavities that are in the tubing of that Willamette meteorite. Let me show it to you. All right, here's even a closer shot of the black and the red. Now, let's look at a real, you can see, there it is. Now, these little different crystal patterns are different types of metals finding their partners. This one is the red one. This is the artery up here. Now, every now and then you'll pick up a little bit of tubing in there, but there's not much tubing in this, because the tubing shows up different than the gooey stuff. The tubing is running through there, and it's a little different. Now, you see up here, remember I said about the edge? You see there's red blood in there. This is the membrane that goes around it. And I'll show you the membrane on this one, because this one didn't burn off like that, because it's just much smaller. And where you have all these little cavities and so forth, there's still actually literally red blood in it. And I'm going to show you that, and I can prove it by putting in hydrogen peroxide, which picks up on, it's called catalase, and it turns into bubbles like crazy, and that's in your blood. Catalase is an enzyme that's in your blood. If it's in here, it means this was blood, and it is in here. All right, that's the Willamette meteorite. It's exactly like this. And here's how this thing came through space. You see how it's got a point almost down here, and a huge hole, and all these little this came through something like this. And then it just sort of wrapped around and made this form. It must have come in like a bullet instead of tumbling. If they come in like a bullet, they stay together. If they tumble, they go flying apart. Now, this looks like this is the tip of the bullet. And that's a bullet you would not want to be hit by. Now, all of these little holes in here are exactly identical to these. And if you get up real close, you can see all the little entryways that are the alveoli. And this is all plumbing. Now, there's red blood in here still. And if you drilled into here, you would also be able to find red blood here and there along the tubing pathways. Okay, this is a meteorite, and it's called a condrite. What it is, it's a lung that didn't burn off like the other lungs. You see all these different colored, this is another one that's identical to this. These colors here are transition metals, and those are too. This is a little bit cooked up, so you end up getting a little bit better color. This, you see, I don't know if you can see the angle. You see on the angle here, you see a real shiny, and then in between the shiny, you see that brownish looking dull stuff. That's where the blood was. And all these shiny parts are where the alveoli were. Identical, same thing, only this is terrestrial. That was a meteorite. You see this? This was from NASA. They showed a meteorite that they had. You see that little brown spot and that brown spot? I'm showing I got the exact same thing. This is it right here. If you could look at the front of this, it's going to look like this. I can almost guarantee you, because that is this bone. It's the same bone. And those are the two holes in the top. They link, I don't know, blood or vein, or artery, vein probably. But anyway, I have these things, and I have the same things they have. I'm going to show literally everything that they're showing that's coming out of space, I have here in my shop. And I have them, really, a meteorite here with blood in it. Let me just show you, and it's this one right here. That meteorite has blood in it. It's this. This is the one right here. You see it? Now we're going to put some hydrogen peroxide in those lung alveoli, in the cavities, and we'll put a little water. You see, they're saturated with blood. There's just tons of blood in here. Let's check it out. All right, keep your eye on this now. We got it in the microscope, and here it is. Let me crank this thing up. Now, what are we looking at? Hold on, let me go full screen. All right, now, that is that little lung. All right, the little magnetic lung I have here. You see, here's the magnets. All right, sticking off of it. All right, now what is these? What are these little spots here? That's blood. What's this little white spot? What's going on with that? Let's look around and see if we can find any more of those white spots. Look at that, they're all over the place. They're all over the place. I wonder what that's from. Well, I don't wonder because I know what it's from. But you might wonder. And guess what you see in that guy's meteorite? Well, actually you see it in the one I showed you, the lung that I showed you, all these little brown spots, or white spots. You might find that in that other guy's meteorite. You have to look up close. This is kind of magnified. Now, let's put some hydrogen peroxide in these bloody areas and see if we can bring up some bubbles, which means there's be catalase there. And if there's catalase there, it means that's the enzyme that the body produces. And I believe we will see it's there. Now let me get this all balanced up and get some hydrogen peroxide. We'll check it out. Don't forget, this is the iron meteorite. This is the one. Here it is right here. Whoops. The magnet goes down to the metal. It's more magnetic. This is quite magnetic as well. All right, so we're going to watch this. Watch, I put it next to that screw. You see the head of the screw right down here? It'll go to that. It's better because it likes denser metal, quite obviously. Let's see what we can do with that. Can we create any bubbles? Okay, this was cooked off pretty good. Usually they really bubble up. This is after maybe, it's got to be close to over 5 minutes. You can see it bubbling off here. You see it bubbling up out of this one. This one's not a bad one. Usually they bubble like crazy just all over. But all of these tubings will also be spitting out particles. I mean bubbles. You see it? Whoops, let me home in on that. You see them spitting out of here? That's the catalase working. Catalase is the enzyme that your body makes to protect you from hydrogen peroxide. So it's turning the hydrogen peroxide into water to save you from reactive oxygen species. It's not complicated, but you just have to know a couple of things. And you see, this one's bubbling up out of here. You see it bubbling out of here? They're all going to bubble out wherever there's blood. That one there bubbled pretty good. You see it bubbling? Now, this white stuff, I'm going to show you what that is. You see it all? I don't know if you're, let me see if I can find some more. That's pretty bright. Hold on, let me back it out of there. Boom. You see that little, let me shut the light down a little bit. Hold on a second. Alright, here we go. Now, look at how bloody this thing is. It's unbelievable. Now, these are the little fabrics that are in the tissue that surrounds a lung. It's called pleurer. I'm going to show you that. Look at this. I mean, this came out of space. I'm telling you right now, it's magnetic. And it's a lung. It's what they call an iron lung.